Question 11. Two quite distinct bits to go. That you're told just first of all to find the point of inflection. Now we've been given that f dashed of x here is, they've given that in the question. But if I want the point of inflection, I need to find the second derivative. Let's differentiate that again, gives me minus 4 minus 6x, doesn't it? And at the point of inflection, f dashed of x equals 0. And so minus 4 minus 6x equals 0. What's that? Minus 4 equals 6x. And so x equals minus 2/3. Now there's a tiny bit more to check just to make sure that this is a point of inflection. In that, what do I want to do? I need to find something that's just slightly to the left of that. So say for example minus 0.7, and also find something slightly to the right of that. And that one there of course turns out to be positive. So that's greater than 0. This one here turns out to be negative. That's less than 0, and so because the curvature is changing from positive to negative at that point there, I'm going to put therefore x equals minus 2/3 is a point of inflection. I think most people are going to get 2 out of 3 there because I don't think they're going to be formal enough at that point. Now for the second part, I've actually got to try and find out what f of x is. Now, f of x is going to be this thing integrated down there. So I'm going to get kx plus 2x squared, not plus, minus 2x squared. And I've also got minus x cubed there then. I'll put a plus c on the end of it. I won't need it, I'll show you why in a second then. I'm going to factorise out the x here, so I've got x lots of k minus, does that say that says a 2, didn't it? K minus 2x minus x squared plus c. Now, why I don't need a plus c is that I actually know it's crossing through here at 0, 0. So x equals 0, f of 0 equals 0. So that means I do know that the c is equal to 0 there. And when does this thing equal 0 then? So I've got x squared plus 2x minus k. I've just times this by minus 1. And I want that to equal 0. I need to know these 2 points here are when that equals 0. So let's solve this. This gives me x equals minus b plus or minus the square root of b squared minus 4ac all over 2a, divided by 2, so I've got minus 2 plus or minus 4 lots of 1 plus k all over 2. That's minus 1 plus the square root of 1 plus k, that's one of them, and minus 1 minus the square root of 1 plus k. That's the other one. The distance between the two of them would be that one take away that one. That means the minus ones will end up cancelling out. That means I'm going to get 2 the square root of 1 plus k there. It's the distance between the two of them. The distance between the two of them is 4 root 2's. So divide both sides by root 2. Divide both sides by 2. Square it. And take away 1. Gives me that k is equal to 7. That's my answer. So what I did there was I solved the quadratic here, found out the two answers, found out the difference between the two answers, put that difference equal to what we were told here, rearrange to get what K was.